Hey everyone, this is our final video. I know originally, if you've been watching the videos consistently, I said there were only going to be 2 videos on the derivatives of trig functions, but my second video got a little long, so I made a third, and this third video is going to take care of this last page of examples if you weren't in class. So let's take a look at example 4. We're still just finding derivatives using trig functions. So we are given this y, so let's find dy dx. Okay, so the derivative of 4 is 0, gone. The derivative of x is just 1, minus, and now I've got to find the derivative of cosecant. So I look back, derivative of cosecant x is negative cosecant x times cotangent x. So negative cosecant x times cotangent x. What you got to be careful here is of the double negative. So this minus is just part of the problem. This minus is the derivative of cosecant. So my final answer then, simplified, would be 1 plus cosecant x times cotangent x. Final answer. Okay, let's look at example 5. What's interesting about this one is when you look at something like 5 times cosine x and 3 times cotan x, these are actually product rules. You really do have like a UV situation going on in each of these. So when I do my derivative, dy dx, I'm going to follow the product rule. So for 5 times cosine x, I'm going to do the first times the derivative of the second. Derivative of cosine is negative sine, plus the second, cosine x, times the derivative of 5, which is 0. So that's the first product rule. Then I have this minus. I'm going to bring that down. Now I'm going to open a parentheses because when I go to do my next product rule, this minus will have to apply to the whole back quantity. Okay, minus. Okay, first times derivative of second. The derivative of cotan x, if you don't remember, look back. Cotan is negative cosecant squared x. Plus the second, cotan x, times the derivative of the first, which is 0. So, final answer. 5 times negative sine x is negative 5 sine x. Cosine x times 0 will drop out. Here, the negative times the negative here will make positive 3 cosecant squared x, and this will drop out. So here is my final answer. Okay? Example 6, we've got what looks like either a quotient rule or a power rule if you bring it up, and I think that's what I'd like to do. I think I'm going to rewrite this as x to the negative second power plus 6 secant x. Then I can use the power rule and the product rule. So my dy dx will be, by power rule, I'm going to bring the negative 2, so negative 2x to the negative 3, plus, now I've got a product rule. First times the derivative of the second. The derivative of secant x is secant x times tangent x, plus the second, secant x, times the derivative of the first, which is 0. Final answer. Bringing this back with no negative exponents, I'll write it as negative 2 over x to the third plus 6 secant x tangent x, because that's going to go to 0. Final answer. And last but not least, example 7. Here is our y. And again, we've got a power rule followed by a product. So dy dx. The derivative of 6x to the third is 18x squared minus quantity first times derivative of second. The derivative of cotangent x is negative cosecant squared x plus the second, cotangent x, times the derivative of the first, which is 1. So my final answer, 18x squared. Here, this negative times this negative will give me plus x cosecant squared x, and then minus cotan x. And that is now a complete lesson on the derivatives of trig functions. Thanks for watching.